Hi guys, I hope everything is going well with yourselves and your families during all this COVID craziness. So today we're going to be continuing our study of gases and the atmosphere. In particular, we're going to be looking at Boyle's law. So you're probably wondering, what Boyle's law is. So pretty much what it boils down to is that the pressure of a gas is inversely proportional to the volume of a gas. And in case you're wondering what inversely proportional means, inversely proportional means that as one goes up, the other goes down, and vice versa. So, for example, if the pressure of a gas is increasing, then the volume of the gas must be decreasing. They're pretty much opposites. So, I like to think about it in terms of a diagram. So, let's look at these two canisters of gas. So in both of these canisters, they both have the same number of molecules of gas, so they both have 5 molecules of gas. But in the right hand side, we can see that that the volume has been reduced by half pretty much. So we've reduced the pressure, and since we've reduced the volume, not the pressure, and since we've reduced the volume, the pressure has been increased. Okay? And the pressure is increased in this example because the space that the molecules of gas have to move around in has been reduced. So because there's less space for the molecules of gas to move around, they're going to collide with the walls of the container more. And because there are going to be more collisions, the pressure of the gas is going to be higher. We can sometimes think about the pressure of a gas as being analogous to the concentration of a gas. So because the concentration of gas molecules is higher per unit area, the pressure is higher. So in terms of an equation, we write Boyle's down law this way by saying P1 multiplied by V1 equals P2 multiplied by V2. So what this means is that if we take our initial pressure and multiply it by our initial volume, it will equal our final pressure multiplied by the final volume. So we're going to just quickly take a look through a calculation so that we're starting to be comfortable with how to do these sorts of calculations. So let's first take a look at this. So it says a gas has an initial volume of 4.0 liters and an initial pressure of 1.0 atmosphere. If the volume is changed to 5.0 liters, what is the pressure? So the first thing you need to do is identify your 4 variables, P1, V1, and P2, V2. So that's the first step. Okay? So you write down P1, V1, P2, V2, and then you fill in the numbers. So the initial pressure is 1.0 atmosphere, so you write that down. The initial volume is 4.0 liters. We want to find the final pressure, or P2, so I put a question mark. And then we know that the final volume is 5.0 liters. So once we've identified our 4 variables, we're just going to write down the equation so that we remember it. So it's P1 V1 equals P2 V2. So what we're going to do is fill in the values from the question. So that's going to become 1.0 atmospheres multiplied by 4.0 liters equals P2 times 5.0 liters. So obviously we want to get P2 by itself since we're trying to find what P2 is. And in order to do that, we're going to divide both sides of the equation by 5.0 liters. And that's what it sort of looked like here. Okay, so the liters and liters are going to cancel. Remember, we have the unit on both the bottom and the top, it cancels. So those units cancel out, leaving only atmospheres. And once we punch that into our calculator, we're going to get a final answer of 0.8 atmospheres equals P2. So the last step in a Boyle's law question is kind of like a common sense check. So in this question, we know that volume changed from 4.0 liters to 5 liters. So we know that volume went up. So if volume went up, according to Boyle's law, we know that the pressure must have gone down. So our initial pressure was 1.0 atmospheres and we calculated the final pressure to be 0.8. And that makes sense because it's less than the initial pressure of 1.0. So it makes sense. One last thing to note, you need to ensure that the units all agree / they're all the same. So for example, both of the volumes in this question were given in liters. It's really important to make sure that the units of volume agree and the units of pressure agree. So you need to make sure both are in liters and one isn't in liters and the other's in centimeters cubed. And you need to make sure if the question had given you both of the pressures, that both were in atmospheres, for example, and not one was in atmospheres and one was in kilopascals. Okay, so let's do another example really quickly. Before we do that, I'm just going to run through the notes so that you can fill out your booklet. Okay. So again, Boyle's law was discovered by an Irish chemist called Robert Boyle. And again, the big takeaway message is that pressure is inversely proportional to volume. So pressure inversely proportional to volume. That's the big takeaway. Okay? And again, in terms of math, we know that the equation is P1V1 equals P2V2. Okay? And with respect to this part here, it's not really important for us to be aware of that. That's just going a little bit more into detail about how to calculate constants for mathematical relationships. We're not going to really focus on that too much. So if we were to plot pressure against volume, it's going to give us a downward sloping curve like this. And that's because as pressure is increasing along the y-axis, we can see that volume is doing the opposite. So if pressure and volume are directly proportional, i.e. both going up or both going down, it would have a shape sort of like this. Okay? But again, it has this downward sloping curve shape because of that inversely proportional relationship. Okay, and again, that's just the equation there, P1V1 equals P2V2. So let's take a look at the sample problem on page 26. So it says a helium gas in a balloon is compressed from 4 liters to 2.5 liters at constant pressure. The gas pressure at 4.0 liters is 210 kilopascals. Determine the pressure at 2.5 liters. So again, the first thing to do is write down your 4 variables and fill in their values from the question, which has already been done here. Okay, then we rewrite the equation so we remember P1V1 equals P2V2. So P1 is 210.0 kilopascals, V1 is 4.00 liters, equals P2, which we're still trying to find, multiplied by 2.5 liters. Okay, so to get P2 on its own, we're going to divide both sides by 2.5 liters. Okay, and the 2.5 liters will cancel like that. And then we just remember the 2 liters cancel, and then we're going to put in our calculator 210 multiplied by 4 divided by 2.5. That's going to give us 336 kilopascals equals P2. Okay, so again, let's do a common sense check. So we know that our initial volume was 4.0 liters and our final volume was 2.5 liters. So we know that volume went down. And because volume went down, we know that Boyle's law tells us that pressure will go up. Okay, and it did. Because our initial pressure was 210 kilopascals and our final pressure is 336. So it makes sense. Okay, and before I do another example, I'm just going to quickly open up the blinds so that there's more light in here. Okay, hopefully that's better. Still kind of dark in here, but whatever. Okay, so let's do two examples again on page 27. So it says 1.0 liters of a gas at standard temperature and pressure is compressed to 200 and not 200, it's compressed to 473 milliliters. What is the new pressure of the gas? So again, the first thing you need to do is identify your four variables. So P1, V1, P2, V2. Okay, so it says 1.0 liters of gas, so that's going to be our V1. Okay, and it says that it's at standard pressure. So remember, this question didn't actually give us what the initial pressure is, but it's telling us that the gas is at the standard pressure, which hopefully we remember is 1.0 atmospheres. Okay, and it's saying that it's compressed to 473 milliliters, so that's going to be V2. But remember, our units all have to match. So because we were given our V1 in liters, we want to convert V2 to liters as well. So that'll become 0.473 liters. And we'll put a question mark next to P2 because that's what we're trying to find. So we'll rewrite it. P1 V1 equals P2 V2. So that'll be 1.0 atmospheres multiplied by 1.00 liters equals P2 multiplied by 0.473 liters. Again, we want to get P2 by itself, and in order to do that, we need to divide both sides by 0.473 liters. Okay, so we're going to cross that both out. The liters cancel. So what that's going to be is 1 times 1, which is 1, divided by 0.473, and that's going to give us 2.11 atmospheres equals P2. So let's do our common sense check. So we know that our pressure our volume initially was 1.00 liters, and our final volume was 0.473 liters. So we know volume went down. So because volume went down, we would have expected pressure to increase, which it did, because our initial pressure was 1.0 atmospheres and our final pressure was 2.11 atmospheres. So pressure went up, it makes sense. Okay, so that's pretty much it for Boyle's Law and what you need to be aware of. I might post another video going through some more examples, but that's pretty much it. You just need to remember volume and pressure are inversely proportional, so as one goes up, the other goes down. And you need to remember the formula P1 V1 equals P2 V2. And remember, the units always have to be the same. And that's pretty much it.